Hello class. In this lecture, we will talk about Kirchoff's voltage law, the other law given by Kirchhoff. It basically deals with the voltage and is also one of the basic laws of electricity. So let us start. Kirchhoff's voltage law, or this is also known as the second law or loop law. The principle of this law is to conserve energy. As KCL was based on the law of conservation of charge, KVL is based on law of conservation of energy, which means energy can neither be created nor destroyed. This law states that the sum of voltage is in a closed loop is zero. It states that for example, in this figure, the sum of voltages or voltage drops in a circuit is always zero. Like KCL dealt with the currents of the circuit, this law deals with the voltages involved in a circuit. The total amount of energy gained is equal to the total energy lost per unit charge. So which basically means if we equate the two terms, if KCL meant the algebraic sum of all currents is zero, KVL means the algebraic sum of all branch voltages. Let me focus on the term the algebraic sum of all branch voltages around a closed loop path is zero at all instant of time. So at any moment of the time in a closed loop, the voltage drops in a branch is always zero. Their sum is always zero. Here, the voltage drops from plus to negative are taken as positive. If in a path, firstly a positive and then a negative appears, it is written as plus. It's and if it's from negative to positive, it's written as negative. What I mean by this, let me further explain this on the whiteboard. In a circuit, if in a circuit, for example, like this, there is a resistance, there is a inductor, and then is a capacitor like this, and it has a voltage source from minus to plus. And this is the path. And if this resistance is R, written as R, this is L, and this is C. And this will be the closed path I, followed by the current. Path is always of the current. And here, this is positive, this is negative, this is positive, this is negative, this is positive, this is negative, which means we are will have a positive sign. VL will have a positive sign, and VC will also have a positive sign. But if consider this voltage source V here, in this circuit, if we see the current is going from negative to positive, and so we will represent this as minus of V. So how will be the equation written? The equation, let me erase, equation will be written as V R VR plus VL plus VC minus of V is equal to 0. The algebraic sum will always be 0. This is what I mean by the algebraic sum. Similarly, if we take the negative term on the right hand side, we will get VR plus VL plus VC is equal to V. Let me write this. If we can say that VR, VR dissipates energy, VL dissipates energy, VC it stores and then dissipates energy. Means and V is the source of energy. This dissipates, and this dissipates. This provides energy, and thus KCL says energy in a circuit dissipated is equal to energy provided by the source, and thus it is based on law of conservation of energy. As we can further state, we can write I can write V voltage drop at any system V is equal to voltage drop is equal to work divided by charge. Okay, and for VR I can write V for VR I can write W of R divided by Q plus W of L divided by Q plus W of C divided by Q is equal to the total work done divided by charge. These Q can be cancelled, and thus we can write WR, work done by R, plus work done by C, plus L, plus work done by C is equal to total work. And thus this law is based on law of conservation of energy. But we have to take a few points as a reminder here. So KVL applies only in case of lumped circuit, like the other law KCL, which also applies in lumped circuits. KVL also applies at lumped circuits. In case of distributed networks, for example, the transmission lines are which have a distributed kind of network, there KVL and KCL don't apply. It is independent of nature of the element. KVL and KCL, these are independent of the nature of the element. If it's any circuit which has a closed path and has resistance, it doesn't depend on the nature of the resistance. If it's a resistance, it will create a voltage drop. Similarly, for other elements, it is independent of the nature of the element. And thus, KVL states that in any lumped circuit, for example, like this, for example, in a circuit like this, if we choose, now I am taking only two elements, if we choose a closed path, for example, the path chosen this time is here like this. Let me take another example. Let us take another path. For example, this is the plus, this is the minus, this is the plus, this is minus, this is minus, this is plus. And now I will take path as reverse. What have I told you? Now VR resistance drop across R will be negative. Why? Because the path of the current goes from minus to plus. Or similarly for VC, VC will be minus of VC, and V voltage source will be positive, because here in this case it goes from positive to negative, so V will be positive. In this case, we can write the equation as V voltage source V is equal to VR. If I erase this equality in the beginning, VR minus of V minus VR minus of V of C is equal to 0. So if current flows from negative terminal to positive terminal, we have to write it negative. If it travels from positive terminal to negative, we have to take it as positive. This we have to keep in consideration while writing the loop equations in the KVL.